Welcome to Acronym Academy, where we build understanding by breaking down the complex acronyms that are, well, absolutely everywhere, especially when you get into tech.
They really are.
Today, we're diving deep into the foundational language you'll need if you're exploring a career in technology. We're focusing specifically on the CompTIA Tech Plus certification, version 6. That's the one with the exam code FC0-U71.
That's right. And the CompTIA Tech Plus is, widely seen as a really essential starting point. It's designed to give anyone looking to get into tech that basic knowledge and, importantly, those practical hands-on skills.
Right.
It covers things like understanding core concepts, learning how to troubleshoot, the basic issues you'll actually see day to day, and just generally building a solid base for wherever you decide to go next in the IT industry.
And our mission today, well, it's to tackle one of the biggest hurdles when you're starting out. Just the sheer volume of acronyms. We've got a pretty big list associated with this certification, and we're going to break them down.
Yep.
Think of this as building your initial tech vocabulary, like learning the basic words before you can form full sentences. Getting these acronyms down is really key to understanding the conversation.
It really is. Knowing these isn't just about passing the Tech Plus exam, though it's definitely needed for that. It's fundamental. You need it for reading technical documents, understanding error messages, talking to colleagues, basically feeling confident navigating the whole digital landscape.
They're the shorthand, right? The language everyone uses.
Exactly. The common language.
So let's start building this vocabulary. We'll try grouping these logically and make them a bit easier to digest. First up, the core computing components, the bits that are absolutely essential for a computer to even, function. Right at the center, you've got the brain, the CPU.
CPU, yeah. Central Processing Unit, that's the primary processor. It executes most of the instructions that make the computer run. It's where the main thinking happens, basically.
And alongside it, especially these days, you've got the GPU.
Graphics Processing Unit.
Right.
While the CPU handles the general tasks, the GPU is really specialized. It's designed for rendering images, videos, complex graphics really quickly.
So if the CPU is the main brain calculating things, the GPU is kind of the visual cortex, focusing on what you see.
That's a good way to put it, yeah. It handles the visuals. Then you have memory. There's RAM.
RAM, random access memory, often called the computer's short-term memory, or its workspace.
Exactly. It's where the computer temporarily stores the data and programs it's actively using right now. This allows for super fast access. Generally, more RAM means you can juggle more programs or work with bigger files without things slowing down.
Like having a bigger desk,
Yeah.
right? More RAM, bigger desk. You can spread out more papers and books your data and programs and switch between them faster.
Perfect analogy. And contrasting with RAM is ROM, read-only memory. This holds permanent instructions the computer needs just to start up, like the really essential instructions for booting the system.
And that's where BIOS comes in.
Typically, yes. The BIOS, basic input-output system, lives in ROM. It's firmware that kind of wakes up the computer's hardware when you hit the power button, does a quick check, and gets it ready to load the main operating system. Unlike RAM, ROM keeps its data even with the power off, and you generally can't just change what's on it easily.
Okay, so brain, check. Temporary workspace, check. But where does all your stuff, your documents, photos, apps live permanently? That's storage technology. And we've seen a big evolution here, haven't we? The traditional workhorse was the HDD.
The HDD, yeah. Hard disk drive stores data magnetically on spinning platters, almost like tiny record players inside. They're relatively cheap for the amount of storage you get, but they have moving parts that makes them slower and more prone to damage if you knock them around.
And the modern standard really is the SSD.
Solid state drive.
Right.
These use flash memory, kind of like a USB stick or an SD card, but way faster, no moving parts. So you get dramatically quicker access times, faster boot ups, better durability, though they do tend to cost more per gigabyte compared to HDDs.
What about removable stuff like optical discs? Feels a bit old school now, but the terms are still around.
They are. You'll still see references to CD, compact disc, that could be CD-ROM, which is read-only memory, you can't write to it, or CDRW, which is rewritable.
And then came DVD, digital video disc for more capacity, also came in DVD-R, recordable, write once, and DVD-RW, rewritable versions.
And for high-def movies and data, there was BD-ROM, Blu-ray disc, read-only memory, higher capacity again.
Storage isn't always inside the computer, though. What about NAS?
NAS, Network Attached Storage. Yeah, that's a popular solution. It's basically a dedicated box full of drives that connects to your network. Multiple computers or users can access it. Great for backups or shared files in a home or small office.
And for smaller portable storage, we use SD cards all the time, right? Secure digital cards, cameras, phones, lots of devices.
Absolutely. And if you want the absolute fastest performance from an SSD, especially in newer computers, you'll hear about NVMe.
NVMe. Non-volatile memory express. That's the interface, right? Not the storage itself.
Exactly. It's a super fast protocol or interface that lets SSDs talk directly to the motherboard using PCIe. We'll get to that, bypassing some of the older, slower connections. It unlocks the full speed of modern SSDs.
Okay, so speaking of how things talk to each other, let's dive into computer interfaces and connections. These are the ports, the slots, the cables that let components inside the computer and devices outside communicate. The most familiar one today has got to be USB.
USB Universal Serial Bus, for sure. It's become the standard for connecting pretty much everything. You've got the classic rectangular USB-A ports we've all used for years.
Still everywhere.
Yep. And then there's the newer, smaller, reversible USB-C connector. That one's rapidly taking over for everything, charging phones, connecting monitors, external drives, you name it.
Definitely seeing more USB-C. Okay, inside the case, connecting storage drives like SSDs and HDDs. That's usually SATA, right?
SATA, yeah. Serial Advanced Technology Attachment. You'll see those cables connecting the motherboard to the drives. There was also a SATA external SATA. Less common now, but it was for connecting external SATA drives directly, trying to get faster speeds than older USB versions offered.
Now, our list also includes IDE. This one's a bit tricky, isn't it?
It can be. Historically, IDE stood for Integrated Drive Electronics, an interface standard for hard drives sometimes called PATA or Parallel ATA. It's the older, wider ribbon cable connection.
Okay.
But yeah, be careful, because in modern tech speak, IDE almost always means Integrated Development Environment. That's a software tool for programmers. Given the context here of foundational hardware for Tech Plus, they probably mean the old hardware interface standard. But it's definitely worth knowing that dual meaning exists.
Good flag. Very important distinction. Okay, back to hardware interfaces. Expansion cards. Like graphics cards, network cards, they plug into slots on the motherboard. Historically, that was PCI.
Peripheral Component Interconnect, yeah. Standard.
But today, it's all about PCIe, right?
Yeah.
Peripheral Component Interconnect Express.
Exactly. Much faster. PCIe provides dedicated high-speed lanes for each device. Absolutely crucial for things like modern graphics cards that just need massive amounts of bandwidth.
Okay, monitors, how do we connect those? Older connections include VGA.
Video graphics array, the old blue analog connector.
And DVI, digital visual interface. That one could be digital or analog sometimes.
Yeah, it had different versions, but the dominant standard now is definitely HDMI.
HDMI, high definition multimedia interface, transmits both high-def digital video and audio over a single cable. Super common for TVs, monitors, projectors.
Definitely. Now, for physical network cables, you'll encounter terms like RJ.
Registered jack.
Right. The common ones are RJ11, that's typically used for old-style telephone lines, and the slightly wider one, RJ45. That's the standard connector for Ethernet network cables. If you've ever plugged a network cable into your computer or router, you've used an RJ45.
Got it. And for really high-speed connections, often using fiber optics and networking gear like switches.
You'll hear about SFP, small form factor pluggable transceivers. These are little modular interfaces that let network devices connect to different kinds of network cables, like fiber optic or even copper sometimes. Very flexible.
All right, that's how the pieces physically connect. Now, how do devices actually talk to each other, whether it's across the room or across the globe? That gets into networking fundamentals. And at the heart of pretty much all modern networking is IP.
IP, Internet Protocol. Yep. It handles the addressing and routing of data packets. Think of it like the postal service for data. It makes sure information gets sent towards the correct destination address.
And layered on top of IP is TCP.
TCP, Transmission Control Protocol. While IP just sends the packets off, TCP makes sure they arrive reliably and in the correct order. It sets up a connection, checks for errors, and asks for resends if packets get lost or corrupted. Together, they form the core suite. TCP/IP, that's the backbone of the internet and most local networks.
So IP gets it there, TCP makes sure it arrives intact. Makes sense. How do devices get an IP address on the network to begin with? You don't usually type those in manually anymore.
Nope. That's usually handled by DHCP, Dynamic Host Configuration Protocol. It automatically assigns IP addresses and other necessary network settings like the gateway address and DNS servers to devices when they connect. Super convenient.
And how does your computer know the IP address for, say, google.com?
That's DNS, the domain name system. DNS acts like a massive internet phone book. It translates the human-friendly website names we type, like google.com, into the numerical IP addresses that computers actually use to find each other.
Got it. Now, networks come in different sizes, right? We hear LAN a lot.
LAN, local area network. That's a network confined to a small area like your home, an office floor, or a single building.
And bigger than that.
You have WAN, wide area network, that covers a much larger geographical area connecting different offices across cities or even countries. The internet itself is the ultimate WAN. There's also MAN, Metropolitan Area Network, which kind of sits in between, maybe spanning a city or a large campus.
What about smaller networks, like connecting my phone to my headphones?
That would be a PAN, a Personal Area Network. It's centered around an individual, connecting devices within their immediate reach. Usually uses technologies like Bluetooth, and if it's wireless, specifically, you might call it a WPAN, Wireless Personal Area Network.
And the term most people know for wireless networking at home or the coffee shop.
That's WLAN, Wireless Local Area Network, commonly just called Wi-Fi. Your connection to the wider internet often goes through your ISP.
Internet service provider, right.
And if you have, say, 5 devices at home, all sharing one internet connection from that ISP, that's likely using NAT.
NAT, Network Address Translation. How does that work, basically?
Essentially, NAT allows multiple devices on your private home network, your LAN, to share the single public IP address given to you by your ISP. It translates the private internal IP addresses to the public one when data goes out, and vice versa when it comes back. It helps conserve the limited pool of public IP addresses.
Okay, and your computer actually connects to the network, wired or wireless, using an NIC.
An NIC, yeah, Network Interface Card, or Network Interface Controller. It's the hardware that provides the network connection. Each NIC has a unique hardware address burned into it called a MASI address, Media Access Control Address, which identifies the device on the local network segment.
And when I look for Wi-Fi networks on my phone, the names I see are the SSIDs.
Exactly. SSID, Service Set Identifier, that's just a broadcast name in the wireless network.
Security for those networks is crucial. We've had a few standards over the years.
Oh yeah. Started with WEP, Wired Equivalency Privacy. Don't use that, it's totally insecure now. Then came WPA, Wireless Protected Access, which was better. Then the standard for a long time was WTA2.
And the newest, most secure one
is WPA3. That's what you should be using if your devices support it. And for mobile data, when you're out and about using your phone's internet,
it's usually LTE, right?
LTE, long-term evolution. Yeah, that's the common standard for fast cellular internet access.
Okay, wow. That's a lot on networking. So devices are connected, they have addresses, they form networks. Now let's talk about the specific languages or protocols they use for different tasks online. Data transfer and protocols. When you just browse the web.
You're using HTTP Hypertext Transfer Protocol. That's the basic protocol for fetching web pages from servers to your browser.
But you often see HTTPS now with a padlock icon.
Right. HTTPS is HTTP secure.
Yep.
It uses SSL secure sockets layer, or more accurately these days, its successor TLS, transport layer security, to encrypt the communication between your browser and the website. Absolutely essential for anything sensitive like online banking or shopping. Even though TLS is the underlying tech, the acronym SSL is still very commonly used, so you need to know it.
Gotcha. What about moving files around, not web pages, but actual files?
For that, there's FTP, File Transfer Protocol, a classic standard. And just like HTTP, it has secure versions. There's FTCS, which is FTP over SSL/TLS. And there's also SFTP, which stands for Secure File Transfer Protocol, but it typically works differently, using SSH Secure Shell for the secure connection and file transfer. Knowing the difference matters for secure file management.
Okay. Email has its own set of languages too, right? For receiving email.
Yep. If you want to check email from multiple devices and leave the messages on the server, you typically use IMAP, Internet Mail Access Protocol, or IMAS for the secure version.
And the other way? downloading it to one place.
That's POP, Post Office Protocol, usually POP3 version 3. It typically downloads the email to your device and removes it from the server, though configurations can vary. And again, POP3S is the secure version.
So IMAP for multi-device access, POP3 for single device download, generally speaking. What about sending email?
For sending, the standard is SMTP, Simple Mail Transfer Protocol, and, you guessed it, SMTPS for the secure version.
Okay. And for network admins managing devices remotely?
They often use SNMP, Simple Network Management Protocol. It lets them monitor and configure network devices like routers and switches.
And if you need to securely log into a remote computer's command line, maybe a Linux server.
That's SSH, Secure Shell. It provides a strong encrypted connection for remote access. Essential tool.
And finally, the web address itself, like acronym.academy.
That's a URL, Uniform Resource Locator. It specifies the location of a resource, like a web page, image, or file on the internet.
Okay, deep breath. Now, here's where understanding the numbers is critical. Units of measurement and speed. In tech, we're always talking about how much data there is and how fast it moves. Let's start with size. Smallest unit is a bit, right? 0, 1?
Yep, and 8 bits make a byte. That's the fundamental unit for measuring file sizes, storage capacity.
So then we get prefixes. KB is kilobit, KB is kilobyte, roughly 1,000.
Right, MB is megabit, MB is megabyte, roughly 1,000,000. GB is gigabit, GB is gigabyte, roughly 1,000,000,000. And TB is terabyte, roughly 1,000,000,000,000 bytes. The key is the lowercase b for bits, often used for network speeds, and the uppercase b for bytes, used for file sizes and storage. Gotta watch that capitalization.
Absolutely critical distinction.
Yeah.
And for speed, we measure in bits per second, BPS.
Bits per second, then you scale up. KBPS, kilobits per second, MBPS, megabits per second, GBPs, gigabits per second.
Our list even includes TBPs, terabits per second.
Yeah, TBPS. That's incredibly fast. You're talking massive backbone connections, data center stuff, usually not your home internet speed yet. But yeah, it's part of the scale.
And for processor speeds, we use hertz.
Right. Megahertz is megahertz, millions of cycles per second, and gigahertz is gigahertz, billions of cycles per second. Higher clock speed often means a faster processor, although other factors like the chip's architecture, like RISC or ARM we'll mention later, play a huge role too. It's not just about the gigahertz number.
Good point. Okay, switching gears slightly. Operating systems and interfaces, the OS.
The OS, operating system, yeah, that's the fundamental software that manages everything, all the hardware, all the other software. It's the platform everything runs on. Windows, Mac OS, Linux, Android, iOS. Those are all operating systems.
Kind of like the conductor of an orchestra, making sure all the parts work together.
Exactly that, coordinating everything.
Yeah.
And how do you interact with that OS, that conductor? One way is the CLI.
Command line interface. Typing commands into a black box, basically.
Pretty much. A terminal window. It can be super powerful, especially for automation, scripting, and system administration. Very efficient once you know the commands.
But what most people use day to day is a GUI.
A GUI, yeah. Graphical user interface. That's where you interact with windows, icons, buttons, menus, using a mouse, keyboard, or touch screen. Much more visual and intuitive for general tasks.
Okay, let's touch on a really critical area now. Security and privacy. As a tech professional, you absolutely need to understand these terms, like EULA.
The EULA, End User License Agreement. That's the legal contract you click Agree to when you install software. It outlines how you're allowed to use it. You should probably read them sometime.
Huh, maybe.
Yeah.
You'll also definitely hear about regulations like GDPR.
GDPR, General Data Protection Regulation, came out of the EU but has had a huge global impact. It governs how personal data must be handled, focusing on privacy and user rights.
And protecting sensitive info is key. Terms like PHI.
Personal health information, very strictly regulated, especially in healthcare.
And PII.
Personally identifiable information, that's any data that could be used to uniquely identify a specific person, name, address, social security number, things like that, needs careful handling.
When you log in somewhere, you might use a PI.
Personal identification number. Yep, common for authentication like at an ATM or on your phone.
Inside the OS, how does it keep track of users and groups for security?
Often using a SID. System identifier. It's a unique value assigned to security principles, users, groups, computers, so the system can manage permissions properly.
And we mentioned SSL earlier with HTTPS.
Secure sockets layer.
Right.
The foundational protocol for encrypting web traffic. Again, technically TLS is the modern standard, but SSL is the term you'll still hear constantly.
Okay, and one practical safety tip when working inside a computer? ESD.
ESD, electrostatic discharge. That's the static electricity zap you can get shuffling across a carpet on a dry day. A tiny zap like that, which you might barely feel, can easily fry sensitive electronic components. So you need to use grounding straps and handle components carefully to prevent ESD damage. Very important.
Definitely good to know. The tech world is always moving, leading to modern concepts and services. These are areas reshaping the industry, like AI.
AI, artificial intelligence, huge field, machine learning, deep learning, it's everywhere now.
And IoT.
The IoT, Internet of Things, connecting everyday objects, thermostats, lights, cameras, fridges to the internet, billions of connected devices.
And VR.
VR, virtual reality, immersive digital experiences, growing fast too.
How we get software and services has changed too. Instead of buying a box of software,
You might use SaaS, software as a service. The software runs in the cloud, you access it through your browser. Think Google Docs or Microsoft 365 online.
and for developers building apps.
There's PayHas, Platform as a Service, provides a platform, databases, operating systems, tools so developers can build and deploy apps without worrying about the underlying servers.
And even more fundamental,
IaaS Infrastructure as a Service. This is like renting the basic building blocks, virtual machines, storage networks from a cloud provider like AWS or Azure. You manage the OS and applications yourself.
there's also DOS.
DIaaS, Desktop as a Service, delivers a virtual desktop environment over the network so you can access your work desktop apps and all from pretty much any device, anywhere.
Communication methods have changed too, making phone calls over the internet.
That's VoIP, Voice over Internet Protocol. Very common now for business and home phone services.
And securely connecting back to your office network when you're working from home.
You'd use a VPN, Virtual Private Network. It creates a secure, encrypted tunnel over the public internet back to the private network.
What about tapping your phone to pay for things?
That's NFC, Near Field Communications. Short-range wireless, used for contactless payments, quick file sharing between phones, things like that.
And finding out where you are.
That relies on GPS, the Global Positioning System. Uses signals from satellites to determine your location.
Okay, let's circle back to some hardware specifics and manufacturing terms. Processor designs. We mentioned RASC earlier.
Right. RASC, Reduced Instruction Set Computer. An approach to processor design focusing on a smaller set of simple, fast instructions. Contrasts with CISC, Complex Instruction Set Computer, like traditional x86 chips.
And a major example of RASC is RM.
RM, yeah. Originally advanced RASC machines. ARM processors are incredibly power efficient. That's why they dominate smartphones and tablets, and they're making big inroads into laptops and even servers now, too.
Memory modules, the sticks of RAM. The common format for desktops is DIMM.
DIMM, Dual Inline Memory Module. That's the standard stick you put in most desktop and server motherboards. Laptops often use smaller SODIMMs.
And the box inside the computer that provides power to everything.
That's the PSU, Power Supply Unit. Converts the AC power from your wall outlet to the various DC voltages the computer components need.
What about when one company makes parts that another company sells under its own brand?
The original maker is often called the OEM, Original Equipment Manufacturer, very common in the tech industry.
And the general term PC.
Personal computer, just a general term for a computer designed for individual use as opposed to a server or mainframe.
In design and engineering fields, you hear CAD.
CAD, Computer-Aided Design, software used to create 2D and 3D designs and models, blueprints, product designs, etc.
And a link to that is CAM.
CAM, Computer-Aided Manufacturing. Software that takes those CAD designs and controls automated machinery like CNC machines to actually manufacture the part.
Okay. In cars or industrial settings, there's a specific network type called CAN.
CAN Controller Area Network. It's a robust vehicle bus standard designed to allow microcontrollers and devices to communicate with each other in applications like cars without needing a central computer. Very reliable.
Other wireless signals, IR.
IR, infrared, like your TV remote control uses, line of sight communication.
And RF.
RF, radio frequency. That covers a huge spectrum used for everything from actual radio broadcasts to Wi-Fi, Bluetooth, cellular signals. Wireless communication that isn't IR is generally RF-based.
What about unwanted signals that can mess things up? EMI.
EMI, electromagnetic interference, electrical noise from various sources that can disrupt the operation of other electronic devices. Shielding cables and proper grounding help mitigate EMI. Technicians sometimes have to track down EMI sources.
And to protect against power outages. A UPS.
UPS, uninterruptible power supply, basically a big battery backup. It provides temporary power if the main electricity cuts out, giving you time to save your work and shut down gracefully, or keeping critical systems running.
Okay, one more major area in modern IT, virtualization, creating software versions of hardware.
Huge concept. It allows for much more efficient use of physical hardware. So you can have a vCPU.
Virtual Central Processing Unit, a software representation of a physical CPU core, right? Shared among virtual machines.
Exactly. And you can have a VHDD, a virtual hard disk drive, essentially a large file stored on physical storage that acts like a complete hard drive to a virtual machine.
And a VNIC.
Virtual Network Interface Card, a software-based network interface that lets a virtual machine connect to the network.
And VRAM.
Virtual Random Access Memory, allocating a portion of the physical machine's RAM to a virtual machine. All these virtual resources, vCPU, VHDD, VNIC, VRAM, are the building blocks that let you run multiple independent virtual machines on a single physical server. It's fundamental to cloud computing and modern data centers.
Okay, nearly there. Lastly, a couple of common multimedia acronyms you'll definitely see. MP3.
MP3, Moving Picture Experts Group Layer 3 Audio, the classic compressed digital audio format, revolutionized digital music.
And MP4.
MP4, Moving Picture Experts Group Layer 4. Not just audio, but a container format. It's commonly used for storing video and audio streams together, sometimes subtitles too. If you watch video online or on your phone, chances are it's in an MP4 container.
Wow, okay. We just ran through quite a few terms there that are absolutely key to foundational tech.
We really did. That list covers a massive range, doesn't it? From the tiny chips inside a computer all the way up to global networks and cloud services. It probably feels a bit like drinking from a fire hose.
You really can, yeah. But getting a handle on these acronyms, understanding what they mean, it's just fundamental. This list really forms the basic vocabulary for the Tech Plus certification, and maybe more importantly, for actually entering the tech field with some confidence and being able to fire what's going on.
Totally agree. Think of it like learning the alphabet and basic grammar before you can read a book or write an email. These acronyms are really that essential foundation. You need them to communicate effectively.
So we've just run through quite a few terms that are key to foundational tech. If you're finding this breakdown helpful, maybe take just a moment to show your support. Like this video, subscribe to Acronym Academy for more breakdowns like this. Maybe share it with someone else who's diving into tech, and definitely leave a comment below with an acronym you'd like us to tackle next.
Yeah, we'd love to hear from you. And as we've been saying, understanding these acronyms, it's not just about passing an exam, although it's vital for that. It's really about building the confidence to navigate the digital world, to speak the language of tech and taking that crucial first step toward a tech career.
Exactly. That's precisely what certifications like CompTIA Tech Plus are designed to help you do, give you that solid base of knowledge and those practical skills. So we finished this deep dive into the language of the CompTIA Tech Plus version 6 certification, tackling this pretty extensive list of acronyms.
Yeah.
It might seem daunting when you see it all laid out like that.
They can be.
But mastering this vocabulary is such a crucial step. It's achievable, and it really helps build that foundational tech knowledge and gain the practical skills you need to get started in IT.
Absolutely. And for anyone out there who is currently studying for the CompTIA Tech Plus V6 exam, that FC0-U71, or maybe any related certification, or even if you're just starting your tech learning journey, seriously, we wish you the very best of luck.
Yeah, good luck.
Remember, learning in tech is a continuous journey. It never really stops. But building this strong foundational understanding first, it's incredibly key to everything that comes after.
Definitely. And maybe here's a final thought for you to mull over. Knowing the definition of an acronym like RAM or IP or TCP, that's powerful information, for sure. But the real strength, the place where foundational tech skills truly shine and where you start to become really effective, that comes from seeing how all these different pieces fit together, how they work together in a complete system. And crucially, being able to figure out why they aren't working when something goes wrong. The ultimate challenge isn't just memorizing the terms, it's applying that knowledge practically. Troubleshooting. That's where foundational tech skills really come into play.
Exactly. It's about putting that vocabulary to work in real-world scenarios. That's where the understanding truly clicks.
Well said. Thanks so much for joining us here on Acronym Academy for this breakdown. Don't forget to like this video, subscribe to the channel so you don't miss our next deep dive, share it with anyone you know who's getting into tech.
Please do.
And leave us that comment below telling us which acronym we should break down next time. See you then.